Today we will see the next experiment, that is experiment number 4, which is called the calculations of the slope and deflections of a continuous beam. Okay, so for calculating the slope and deflection, a typical apparatus which is used in the structural engineering laboratory is as shown on the screen. So this is a typical um, apparatus which is used to calculate the slope and deflection. Okay, so let us see the description of this particular apparatus. Okay, so this is just like a prototype model of a continuous beam on which a number of hangers can be applied, okay, so that the load can be applied on a continuous beam. Okay, so here in this case we are interested in calculating the slope and deflections. Okay, so here in this case we are going to apply a single load, okay, through the hanger at the center of a particular continuous beam. So whenever we will going to apply the particular load on a center, so the beam will going to sag, okay, in a downward direction, and because of that the outer edge of the beam will going to the outer edge of the beam will move in upward directions. That is this part and this part will move in upward directions. Okay, so whatever the portion which moves in upward directions, okay, so because of that we will find the deflection slope from that particular point, and whatever the sagging we will obtain because of the central loading, okay, here, so because of that we will obtain the deflection. Okay, so this procedure is very simple. Okay, so let us see how to perform this practical, okay, in laboratory. So this particular apparatus is used to calculate the slope and deflection of a continuous beam. Okay, so let us see the procedure first. Okay, so this is our aim, to find the slope and deflection of a continuous beam. So basically, theoretically, according to the moment area method, the change of the slope of the tangent of an elastic curve between any 2 points of the deflected beam is equal to m by ei diagram between the 2 points. Okay, so this is a typical beam. Okay, this is a prototype of beam. Here we are going to apply the loads, okay, either at the center or on two extreme edges, okay, so that the beam will going to deflect in downward direction. Okay, so the beam will going to deflect like this. Okay, and this deflection can be calculated at the center, and this deflected shape, whatever is the deflected shape, will going to move in upward direction on either side. Okay, so we will measure that in the form of slope. Okay, so this is a particular free body diagram of a experimental setup. Okay, so here we will get the slope at B will be equal to, this is a B, y2 by B, this y2 by B, this is a triangle we will which is formed. Okay, so when we divide y2 by B, you will get the slope. Okay, similarly here also we will get the same answer. Okay, then this is a suggestive experimental work. Measure the length A, this A length we have to measure, then B length we have to measure, and the total length of the beam we have to calculate. Okay, so whatever the scale which is there as an apparatus or used as an apparatus as a prototype, so we have to measure the length of this scale in the experiment. Okay, then step number 2 is to place the hanger at equal distance from the support, it's not supports, it is from support A, and load them with equal loads. Okay, so why we are applying the equal loads at equal distance? Because we are interested in calculating the deflection, okay, at the corners. So the deflection, in order to calculate the same deflection at both the corner, so we have to apply the concentric load at a particular distance, at equal distance and with an equal magnitude. Okay, so like this we have to apply the two equal loads with equal magnitudes, then measure the deflection by the dial gauge at the end B, y2, and center C. Now we can calculate the y2 deflection here, okay, and at center C point we can also calculate the deflections. So deflection can be calculated at the center as well as at the corners, okay. So deflection can be calculated on two sides. Then repeat the above step for the different loads. So we can repeat the number of cases, okay. So resultant discussion, what we are going to do is calculate the slope at B is equal to y2 by B as measured value, then compute the slope and deflection at B theoretically, form and BMT and compared with the experimental value, okay. So we can compare this value, okay, with slope, okay. Then deflection at C is equal to y1, this C is equal to y1, so we can plot C is equal to y1 and deflection at C is equal to average value, okay. The sample data sheet can be calculated. The length of the span, length of the overhang portion and modulus of elasticity of steel is equal to 2 into 10 to the power 6. Why this modulus of elasticity of steel is considered? Because we are considering the continuous beam as a scale, okay, which is built up of the steel material, okay, and we know that the modulus of elasticity of steel is 2 into 10 to the power 6, okay. So what is the comment of the particular case? The moment area theorem may be often be used more conveniently in computation of the slope and deflection of a beam and frame, and practically when the deformation is caused by the concentrated rather than the distributed loads, okay. So these theorems are based on the consideration of the geometry of the elastic curve and curve of the beam and the relation between the rate of change of slope and the bending moment at a particular point on the elastic curve, okay. So these are the particular precautions, okay. So this experiment is very simple, okay. So once again I will show you how to calculate the or how you will perform this practical. So this is a two hanger, okay. Here this is a particular scale is there which act as a continuous beam, okay. So you have to place the hanger at an equal distance from left hand side as well as from the right hand side. Suppose this A distance is 5 centimeters, so here also from B point it is also measured, it should be measured as 5 centimeter. Now the whatever the load you are going to take, suppose here we are adding 50 grams, so here also you have to add the 50 grams, okay. So equal distance and equal magnitude, this particular pattern you have to follow, okay. So when we apply this particular loading as well as the place the load at a particular distance, so you will get the deflection here at the center as well as at the corner, okay, because beam will try to deflect like this, the beam will try to deflect like this. So here you will get the slope like this, y2 by C, here also y1 by C1 and here y2 by C2. So you can calculate the particular slope here also, and you can calculate the deflection by putting this dial gauges, okay, at the tip of the scale at the corner as well as at the below this particular deflected area or deflected portion, okay. So you can easily measure the deflection here and here as well as the slope by the geometry of this particular triangle, okay. So this particular experiment is used, okay, is most commonly used to calculate the as a prototype model for calculating the slope and deflection of a continuous beam, okay. In practice also, okay, in theoretical portion or in practice also, there are n number of methods which are used in structural engineering by which we can easily calculate the slope and deflection. One most commonly method is the slope and deflection method, okay, which we will going to study in our next theory class, that is under the unit number 4, and that method is itself called as a slope and deflection method, which is most extensively used for calculating the particular slope and deflection of any particular beam, either it may be continuous beam, maybe cantilever beam, maybe or simply supported beam, okay. So this equation, particular equation, that is a slope deflection equation, we will going to form in theory, and that equation will be used to analyze the structure that is an indeterminate structure, to get the unknowns in the form of slope and deflections. Okay, so this was today's experiment. Okay, I will provide you the reading for the same, that is to find the slope and deflection of a continuous beam in PDF format in your Google Classrooms. Okay, so just try to understand this. Okay, and write in your essay manual. Okay, and make the PDF and submit that particular PDF in Google Classroom under the folder of experiment number 3. Okay, so thank you very much for your kind attentions. Thank you.